Hello, everyone. Super excited to be here, and super excited that you actually see that you survived the party yesterday. I thought I would walk to an empty stage, but seeing you here today, it's really beautiful. So, my name is Nicola Corti. I'm an engineer on the React team, and today I'm here with Riccardo and Kari to talk about my favorite topic. You guessed it. It's React Native. Yeah, folks? Awesome. Well, in case you don't know React Native is our toolkit to bring your React code from web to native, to let you build delightful experiences. Like the ReactConf app that we built to give you a glimpse of what you can do today with React Native. Go download it on the Play Store and App Store if you haven't done it yet. So we need to go back to 2015, ReactConf 2015, our first open source release of React Native. But again, today I'm so excited to be here because we have so much content to share. So let me walk you through what we're going to talk about today. And we're going to talk about three things. First, I want to talk about the state of React Native. Then, we want to share some updates on the new capabilities that are available in the latest version of React Native. And then, we want to share some updates and tips on what we believe is the best way for you to build production-ready apps in 2024. So let's start with the state of React Native. How about we take a look at the weekly download count for the React Native NPM package. The last time we spoke at ReactConf 2021, we were at 600,000. But now, I'm excited to share that we just smashed the 2 million weekly downloads for React Native. And if 2 million is not impressive enough, let's look at the yearly download count. We started small, but I'm excited to share that only in 2023, you folks downloaded React Native more than 78 million times. And I can't wait to see where you're going to bring us next. So now, it's not just about downloads, right? Our project is more active than ever. Only in the first 5 months of 2024, we shipped 19 patch releases. So back in the day, we used to ship a lot of minor releases with a lot of breaking changes. Now, we moved to a model that let us ship faster, but also ship less breaking changes. So updating React Native is not going to be a painful experience as it was back in the day. Recently, we also shipped our latest stable, React Native 0.74. And this accounts for a grand total of 30 shipped versions only in the first months of 2024. And you'll be amazed to see what's inside the latest stable of React Native 0.74. We shipped more than 1,600 commits. Those are bug fixes, new features, new capabilities, bumps of libraries, and so on. And I really want to take a moment to thank the folks in the release crew from companies such as Microsoft, Shopify, Coinbase, and Expo that help us make this release possible. But now, let's talk a bit about which companies and which partners are out there are investing hard on React Native. Well, obviously, as at Meta, we're using React Native quite aggressively in a lot of our apps, such as Facebook, Meta Quest app, and much more. But then, we also have Microsoft, one of our stronger partners. They're a leader in desktop development, with desktop applications such as Office and many more. Then, Amazon is also another key partner of ours. They've been using React Native in a lot of their mobile apps. And I'm sure you don't want to miss the talk from Chris and Anisha just after the keynote, where they will talk about how they're extending React Native beyond just mobile and desktop. But then a lot of other partners, like Shopify, Wix, and many more. I'm sure that a lot of the apps you use daily on your device are using React Native to some extent. And if you really want to learn more about which apps out there are using React Native today, you definitely don't want to miss the analysis that Evan and the folks at Expo has been doing. They've been scraping the App Store to find out how many apps are using React Native, and you will be impressed to see how many there are. But now, back to Meta for a minute. Because I personally feel that we don't spend enough time talking about how we're using React Native internally. So today I want to share some success stories of us using React and React Native. Well, as you can see today, Meta is heavily invested on the success of both React and React Native. It's like an entire org with engineers and engineering managers fully invested on the success of those frameworks. We do this because we believe in the value that it brings to both Meta and the open source ecosystem. So at Meta, we found out that we have more than 2,500 unique React Native screens across a lot of our products. And only in the Facebook app, we have more than 1,000 screens, with popular features such as dating and many more. But on the Facebook app, our biggest partner so far is definitely Marketplace. You probably know Marketplace if you ever sold or bought items on Facebook. So this page that you see on screen is the product detail page. And today, I'm excited to share that this page is visited daily over 2 billion times. 2 billion times, folks. It's billion, billion with a B. By the time this slide is on screen, this page has been rendered over 200,000 times. We believe that this gives a sense of all the possible display configuration, network condition, device setup that React Native is exposed to. Really, this is the scale at which we are building React Native. And it's not just mobile, right? I want to show you a couple of other products that we built recently. First, this is the Meta Account Center. It's a way for you to link your Facebook, Instagram, and other accounts together. This is how we built it for web, using React. But we obviously wanted to bring the same experience also to VR. So that's how it looks like on Quest devices. Thanks to React and React Native and our infrastructure to share code, we were able to easily bring the same web experience back to native. And if you want to learn more about to share code between platforms, you don't want to miss the talk from my colleague Olga and Naman later today, cross-platform React. And as I'm talking about VR, I can't forget to mention the Quest Store, the place where you can buy new games and experiences for your Quest devices. That's how it looks like on web, built with React. And that's how it looks like on mobile, built with React Native. And again, we wanted to bring that same experience to VR users. So that's how it looks like on Quest devices. Thanks to React, our engineers can easily jump between web code bases and native code bases and share knowledge. So really, this is a testament of how Meta is investing extremely hard on the success of React Native. But it's not just Meta, right? Today, I want to briefly talk about one of our close partners that is also investing extremely hard on React Native, which is Microsoft. Microsoft is one of our key partners, and they've been helping the React Native community in a number of ways, helping us with making releases and building new tooling. But that's not just it. They've been maintaining both React Native Windows and React Native macOS. And they're heavily invested on the success of this framework. A lot of their desktop and mobile apps have been built with React Native, and they've been shipping those apps on both web, Android and iOS, and Mac and Windows. And this is just a handful of apps of how Microsoft is using React Native in production. And today I want to give you a glimpse, one small example of how Microsoft is using React Native. Let's look at this feature. This is Microsoft Word desktop application. And the feature you're about to see, it's called Accessibility Assistant. Let's inspect your document for accessibility issues, such as low contrast or text that is hard to read. This area that you see on the right, the column over there, is entirely written in React Native. And you can see how well it blends with the rest of the desktop application. Folks at Microsoft are using React Native to either create new features like this one or modernize old features. And I want to talk also about another key feature they've been developing with React Native, which is the Windows 11 Start menu. That's the first thing you see whenever you open a Windows 11 PC. This section over here, the recommended section, is entirely written in React Native. Folks at Microsoft have been using React Native to boost the developer velocity because it's easier to onboard new engineers to desktop development with React and React Native. I think it's amazing to see, like, really how Microsoft has built core functionalities for their core products, thanks to React and React Native. So obviously knowing that both Meta, Microsoft, and other big partners are investing in React Native is a huge selling point, right? But I think there is another strong argument when you're using React Native, which is the community. When you're using React Native, you get access to AAA libraries built by our partners and community members. Let me tell you, those libraries are just awesome. Like, literally, I want to spotlight a couple of them because that gives you a sense of what you can build today with React Native and those libraries. The first one is React Native Reanimated. It lets you build delightful animation, which basically bring your application to life. Look how polished those animations are running, and they're running natively on device. We even added some of them inside the ReactConf app for you to experience. And I want to give kudos to folks at Software Mansion, which, by the way, I believe they're here in the audience somewhere, because they've been building this amazing library that is loved by the whole React Native community. So let's give them a big round of applause. Then we have React Native Vision Camera, which lets you unleash all the power of your on-device camera. And lets you do amazing things, like the one we're doing here, the image recognition, motion tracking, and applying filter at real time. Again, kudos for this one goes to Margello for building another amazing library for React Native. And then we have React Native Skia, which lets you use the full power of the Skia rendering engine and lets you build impressive experiences like the one you can see on screen. And kudos for this one goes to Shopify. And I could go on and on and on. But really, this is the beauty of the React Native ecosystem. It's the community. It's the library that are making part of it. And it's the people that are making part of it. I'm always so amazed to see how community-driven React Native is. And I personally believe we will not be where we are today without the help of all of you. So thank you very much. And now, to talk about the new capabilities that are available in the latest version of React Native, I want to invite my colleague, Riccardo, on stage.
Hi, everyone. I'm Riccardo. I'm a software engineer in the React team at Meta. And wow, it's amazing to be here, ReactConf, all amazing people. I'm very excited, almost speechless, which is not great for me right now, but let's get it started. So I want to talk about new capabilities that we are pushing to the React Native core to let you bring all the features that you learned about React yesterday into your native application. And I really cannot talk about new feature without mentioning the new architecture. Let me borrow the words of my colleague, Rick Hanlon, from ReactConf 2021 to describe what the new architecture is. It is basically a rewrite of the internals of React Native to make it synchronous so that we can use concurrent feature in React Native. So let's have a look together at how a React Native application works under the hoods. So in any React Native application, we have a native layer that is used by the system to render platform-specific UI components and let your user interact with your application, and the JavaScript layer that you use to describe your UI and implement your application logic. What you want for these two layers is to communicate with each other, of course. And this is possible thanks to a component that is called the bridge. The bridge lets messages in JSON flow from one side to the other and back. But as you may guess, using JSON requires them to be serialized and deserialized. And this can take time and potentially block your UI. And of course, this is a bad thing. We don't want that. And to avoid this, we had to make React Native asynchronous. This is the old architecture. Let's have a look at how the new architecture works instead. Of course, we still have the two layers, right? We want to render components, and we need to write our logic and UI. And they have to communicate. We basically replaced the bridge with another concept, which is called JSI, or JavaScript interface. Thanks to JSI, we don't communicate with message passaging anymore, but we use memory sharing. So the native layer and the JavaScript layer are sharing memory to communicate. This is, of course, much faster and efficient than before, and this basically let the JavaScript layer run synchronously with the native layer. So the new architecture is not just a rewrite, of course. It enables much more capabilities that you can use directly in your application. Let's start with one that I already mentioned, which is JSI. So what I'm about to show now is something that with the old architecture was not possible to implement properly. We tried a couple of times, like the CPU was skyrocketing, device was overheating, and the result was, well, not great. So have a look at this video. This is React Native Vision Camera. And I want you to focus on the fact that we are running face detection algorithm and face blurring at the same time on device, and look how it sticks, like the blur sticks to the face. I mean, it's amazing. And again, thanks to Margello for developing this amazing library. It's the same that Nico showed you before, but like, let's focus on the blur here. The other feature that the new architecture enables are concurrent React APIs. At the end of the day, we were developing the new architecture to let you use those, right? So let's have a look at one of those examples. Use layout effect. In the old architecture, if, for example, you want to render a tooltip, which is anchored to another view, the anchor in this case is the red box, we need at least 2 rendering passes. One to render the red box and get all the layout information, and the second to use those information to render the tooltip. It's not great, right? With the new architecture and concurrent React APIs, we can use layout effect and get all this information right before the rendering phase, so we can render everything at the same time, and the result is much better and what probably you were expecting. So we first open the usage of the new architecture in React Native 0.68 a couple of years ago. At that time, it was in an experimental phase, and it was hidden behind a feature flag or an opt-in flag. We did that to let you try it out in your application and report feedbacks. And we took your feedback very seriously. One of the feedback that we received the most was that migrating to the new architecture, whether you were developing a library or your actually app, it was taking a lot of effort and a lot of code changes. So in the next few months, we are working on basically 2 features. One is bringing back some API that you were using in the old architecture to the new architecture so that you can start adopting the new architecture without changing any line of code, and several interoperability layers to let your legacy modules and legacy components run smoothly in the new architecture, again, without changing a single line of code. And of course, we didn't stop there. We collaborated with several partners, for example, with Expo, to try out all the Expo modules in SDK 51. And thanks to that experience, we will be able to push fixes in the core so that all the Expo modules in 51 are working smoothly in the new architecture, and you don't have to change a single line of code. This work was when it went really well, and Expo is calling out instruction on the release blog on how to try the new architecture in your application and how to report things that may not be working. Expo was not the only partner we worked together with. We work with Software Mention, CallStack, and other independent maintainers to try out their libraries in the new architecture and push further fixes in core to make sure that every one of you, after ReactConf, can go back home and try their application with the new architecture turned on. And that's why I'm very excited I'm very proud of the team today to announce that we are considering the React Native new architecture officially in beta. So, again, when you go back home and after the conference, you can spin up your application, move it to 74, and if you are using mainly Android, you can turn on the new architecture, modifying the new arc-enable flag on the Gradle.properties file. And for iOS, you can run polystall with the RCT new arc-enable flag set to true. If you're using Expo, migrate to SDK 51, and then you can use the Expo build properties config plugin to turn on the new architecture for both iOS and Android. For more information, this is the link with the announcement, so check it out in the working group. And now, to talk about production-ready application, back to Nico. Shit.
Thanks, Riccardo. So now we want to share some tips and suggestions on what we believe is the best way for you to build production-ready app with React Native in 2024. So I'm personally an Android engineer. I've been doing Android applications for like 10 years plus. And I know how complicated it is to build production-ready apps, 5-star apps, because our devices are changing, our users are changing, and the user requirements are changing as well. So keeping up with the reviews and the quality of the app, it's complicated. So our goal in the React and React Native team is for you to focus on building beautiful application that solves the user needs. We don't want you to spend time on fixing infrastructure issue or like dealing with tooling that is not great. So, like when you open Android Studio and you do like file new project and you create an app, you have the Hello World app running out there. You feel you're an Android developer, no? Like you're ready for production. But to bring that Hello World app from the simulator to the store and let it be a 5-star app, you need a little bit of things. You will have some problems to solve, right? Let's look at them. First, you need solutions for navigation, and routing, and handling deep links. At the end of the day, your apps will have more than one screen, right? And you want your user to be able to navigate between them. You will need some help managing your Xcode project and Gradle file, which are notably quite hard to deal with. You will need some help publishing to the stores. For example, on the App Store, you will have to create screenshots and icons and create a bundle of your app and upload it and so on. Well, then you will have to deal a lot with dependencies and things like making sure they're up to date and they're aligned with each other so they don't clash. And a lot of other features to be like capabilities for your app, like push notification, in-app purchases, splash screen, user authentication, and much more. The list goes on and on and on. And like, really, those problems, any mobile engineer out there will have to solve it to bring your application to 5-star, to bring it to success. And if you've been doing React Native, you probably already know a tool that solves all of those problems and many more, like Expo. So over the last months, we spent time with the rest of the team and with our partner defining what is a tool that solves all of those problems. And we call a tool that does all of this a React Native framework. We recently updated the reactnative.dev website with a recommendation on what are React Native frameworks. Oh, and by the way, we just updated also the landing page of reactnative.dev like 1 hour ago. So go and check it out because we refreshed the website and we bring it up to date with the latest standard. So if you go on the reactnative.dev website, you will find that we define a React Native framework as a toolbox with all the necessary APIs to let you build production-ready application. In a sense, this is really similar to the same concept you have on web, with web frameworks such as Next or Remix. So we're sort of bringing React Native closer to what you have on web. But now you might be wondering, okay, folks, so are you forcing us to use Expo? Are you forcing us to use a framework? Can I use React Native without a framework? The answer is yes, but from our experience, we like to say that you're either using a framework or you're building your own framework. as you're basically solving those issues that I was showing you before, over and over again. Someone already solved those issues for you, so it's pointless that you keep on solving them again. We want you to focus on building production code, on building beautiful application. So that's why, starting from React Native 075, the recommendation from the React Native team for newly created app is for you to use a React Native framework. And our framework of choice is Expo. So yes, you should be using Expo for your newly created app. We believe that Expo today is the fastest way to bring your apps from idea to production. We are obviously open to recommending other React Native framework in the future, because we also published an entire RFC on what are React Native frameworks, why we're making this change, and what are the requirements to become a new React Native framework. And now, to tell you more about what you can build with Expo today, I want to invite Kari on stage.
Thank you, Nico. Hi, everyone. I'm Kari. I'm a developer at Expo. And wow, how great is it to have a React Native keynote at ReactConf again? I feel really privileged to be here today at React's 10+1 birthday at that, to talk to you about building production-ready apps with React Native today. Now, you might have heard it said that building mobile apps is kind of hard, especially for developers coming to React Native from the web. You have higher expectations when it comes to developer experience, because you've lived it, you experienced it, you know how good it could be. And you want the same kind of experience when developing for other platforms. At Expo, we want to bring the React Native developer experience more in line with web dev. Let me show you some of the things that are tricky about native development. First, of course, we are targeting multiple native platforms in a single code base. This is what React Native is all about, allowing us to run React code on native iOS and Android platforms. Now, the really awesome thing about React Native is, of course, that React Native apps are real native apps. So when you create a text input using React Native, it's not secretly rendering it in HTML. It is using the real native text input components for each platform. This is so important for performance and the native look and feel of your app. But it does cause a difficulty for React Native developers. And this is that you need some way of surfacing all of these native functionality to the JavaScript side so you could actually use it in React. So accessing the phone camera, sending push notifications, using Face ID, all of these and more require a native module that bridges this code from the native side and makes it available to the React code. Then we have navigation. Navigation on mobile comes with a ton of nuance and functionality that you don't see on the web. Remember how React Native apps are real native apps? Well, unfortunately, this does mean that you need to also manage some of that native code. You need to keep it up to date. And finally, there is actually building your native app, both for development and deployment. Building native apps is shockingly difficult compared to web dev, and it requires specific native dev tools and a security step called build signing. React Native lets us render React code on the native iOS and Android platforms, but doesn't help with the rest. Let me show you how using a React Native framework does. I am, of course, going to talk about Expo. Expo is a free and open source framework for building universal native apps with React Native. We also built the Expo application services, which is a set of cloud services built specifically for React Native and Expo apps. It is an optional extra which you can choose to use with or without building your app with Expo. The team at Expo have been a constant presence at the React Native community from its very inception. We really believe in the technology, and it's demonstrated by our decade-long commitment to it. For example, we were the first ever to publish we published the first ever React Native community libraries, only a couple of months after the initial release of React Native. We created React Native Directory, a place for searching and discovering React Native libraries. And we helped organize ReactConf back in 2016. We also contributed to React Native directly, being the first external contributors to run a release of React Native. Among other things, we helped add async functions to React Native, and, as you heard from Ricardo earlier, collaborated with Meta to ship the new architecture to open source. And today, we are beyond excited that this has led to the creation of the first React Native framework. What React Native gives us out of the box is the ability to run React code on native iOS and Android platforms. A huge amount of work goes into making this happen. We have Metro for bundling, JSI for communicating between the native and JavaScript layers, Fabric, the native renderer, and of course, Hermes, the JavaScript runtime. And on top of this core functionality, React Native also ships with the most fundamental components, like your text, view, and text input. But the goal of React Native is not to provide access to every single native device capability out of the box. Instead, we are given the API and the mechanism to do it ourselves. And this brings us to the first hard thing about React Native development, and this is accessing these native capabilities. React Native provides the mechanism, but it does not actually expose all the functionality needed to build modern apps. Hence the reliance of community libraries. These are often from people and companies from the community who needed to use functionality from the native side didn't yet exist bindings for. Libraries for animation, maps, vision. And we have built many of these ourselves. And we pulled much of the fundamental functionality together into the Expo SDK, our extended standard library for React Native. It includes a huge amount of components and capabilities that are not included in React Native, but you usually need to build your production app. For example, the SDK includes libraries for common authentication patterns, one to facilitate browser-based OAuth flows, like login with Amazon, the all-important Apple Auth, and a library that lets you use biometrics like Face ID and fingerprint. There's Expo notifications for sending local and remote push notifications. And Expo sensors, which lets you access device sensors that measure motion, orientation, ambient light, and open the door for creating experiences like this one, a neat little game that uses your device orientation as controls. We rarely create libraries that are already included in React Native. But one exception to this is Expo Image, created mostly to provide better compatibility with other image libraries we have, and to support more image formats like SVG. But on top of supporting image formats, it also comes with easily configurable native transition animations. And you can even enable live text interaction on iOS with a single prop. So with these and other React Native modules readily available, you're likely to find an existing library that suits your needs. But if you don't, and you need to write some native code yourself, you'll probably want to use the Expo Modules API, which is built on top of the React Native JSI layer. Now, I know the idea of writing native code may seem a bit daunting if you primarily write JavaScript, and to be honest, it very much was, back when your only options were Objective-C and Java. But the Expo Modules API, in the Expo Modules API, the native code is actually written in Swift and Kotlin. So it tends to feel surprisingly approachable for TypeScript developers. To get started, you can use this npx command to create a new module. And this will create a new project with everything set up ready to be released to NPM. Or you can use the local flag, set it up to use in a private project. In the module, you'll have a place for your native Android, iOS, and web code, as well as an example app ready to set up for testing. Here is an example of a Hello World module where we call a function to receive a greeting from the native code, with implementations for web, Android, and iOS. Then in your React Native code, you can call a single function or your native module and render the platform-specific greeting for each platform. So you can use the Expo Modules API to build additional native capabilities for your own app, or join others in the community who are already using it to share open source libraries. So to access native capabilities, things not already shipped with React Native, we have the libraries in the Expo SDK, plus many community libraries which account for almost any need. And if you do need to build a new native module, you'll have the Expo Modules API. Next on our list is navigation. On the web, you might be used to building your own navigation UIs from scratch. On mobile, users have certain expectations about how the navigation should work. There's a lot of subtle behavior that makes building your own UI completely from scratch a very difficult challenge and something you're likely to get wrong. Let me show you what I mean. Here's the Conf app on Android and iOS. Has everyone downloaded it? Well, there's still time if you want to do that. We're still on day 2, so you can try it out. Try some of the things I'm going to talk about out for yourself. So this app has a bottom tabs layout, a UI pattern that's very much expected on mobile. There's a subtle UX expectation, even on the bottom tabs, that you might not even realize that you and your users have. Like when I scroll down, oh, did I do that? Like when I scroll down on the home page and then tap on the home page tab bar, the screen auto-scrolls to the top. Let's look at navigation between screens. On Android, the talk details page slides in from the left, and to go back, we use the swipe left gesture to go back. On iOS, the screen opens in a modal with an iOS-specific animation, and we actually close the modal with a swipe down gesture. So not only are we adding gesture to the mix now, we also need to support different UX for Android and iOS. Let's look at another example. Let's use the search on the speakers page. On Android, we tap the search icon to start typing. Whereas on iOS, we scroll down to reveal the search input. This is just some of the expected behavior from a navigation system on mobile. There's a lot of platform-specific expectation that would be pretty overwhelming if you try to build it from scratch. So really, you'd probably want to use a navigation library where all of these things are already set up. Our solution to this is Expo Router, which brings file system-based routing to React Native. I'm sure most of you are already familiar with file system-based routing, as there are several frameworks and established patterns already on the web. Let me show you how we made this work in React Native. Here we have a stack navigator with 2 screens and a button to navigate between them. With Expo Router's file system-based navigation, all of your app routes are defined in the app folder. The key to making this work on native is the layout file, which is how we organize the screens and declare how they should be rendered, as tabs, a modal, or in this case, a stack. Notice that I didn't need to list out any of the routes in a stack, and that's because this information is implicit from the file system. You only ever need to define them if you want to add additional properties such as header icons, styling, or in this case, a title for the screen. So with Expo Router, you can create truly native navigation experience for Android and iOS. Not only that, but you can also target the web. That's right. In the same code base, you can build for iOS, Android, web, and even tvOS. And this makes code sharing between all the platforms a real possibility. Furthermore, we've recently added API routes to Expo Router. For React Native, this is beyond exciting, because for the first time ever, we have an easy way to write server-side code inside our React Native code base. So for navigation, you could use Expo Router. It provides a native navigation system that works beautifully on iOS, Android, and web, and tvOS. Next up, we have the native code. I think I pressed this twice. Next up, there's the native code. Although with React Native, we're building applications primarily with JavaScript, we still need to occasionally handle some native code. There are some things that can't be done without it, even with a library, such as changing the app name and icons. And of course, we have the dreaded upgrade React Native experience. With Expo, we have a solution for this, and honestly, it eliminates at least half of what I used to find frustrating as a React Native developer. It's called Continuous Native Generation, or CNG, because who doesn't love an acronym? Let's see how it works. This is the structure of a React Native project. We have our source folder for your JavaScript code, and the iOS and Android folders for the native code for each platform. And this is another folder structure of another React Native project that uses CNG. This is also an expert router project, so we have our app folder for our file system-based routing, and our component folder for the rest of our components, and not a native folder in sight. And that's because this project is using CNG, continuous native generation, to generate these folders. The idea behind CNG is that native code can be generated from a set of inputs, making it ephemeral. I mean, anyone here checking their node modules to Git, for safekeeping? No? Chances are you don't. Chances are you're going to install your node modules based off your package.json and your log file using npm or yarn. So in a similar way, you can run npx expert prebuild to generate the native projects based off of your app.json and package.json. Note that this is not in any way a lock-in. You can always opt out of using this workflow and manage your native folders directly. But let me show you why you might want to use CNG. Who here hasn't heard someone complain about the React Native upgrade experience? I mean, it's basically a running joke in the community at this point, and for a good reason. Recall that React Native includes all these wonderful tools that make React code work for iOS and Android. Well, all this code lives inside the iOS and Android folders. And I think you might already see the problem here. If you check these folders into Git, and then you make additional changes on top for your own project needs, it means that there is no way to automatically, reliably upgrade to a newer version of React Native. You need to do it manually. And I mean really manually. There are tools like the upgrade helper that show you the diff between your current version and the version you want to upgrade to, and you go through every single file and manually copy them into your code base. Who here has done that? Too many times. Even with a CLI tool that adds this diff automatically file by file, you're still left to oversee each merge and resolve the conflicts. Painful indeed. Compare this with how you'd upgrade a React Native project that uses CNG with a single CLI command. You install the newer version of React Native and simply regenerate your native folders with prebuild. Other than upgrades, a huge benefit of CNG is that all of your app config is defined in a single file, in your app config file. Now, I don't know about you, but the first thing I do when I start working on a new app is create the app icon. I used to do the same when I did web dev. New website, adding a favicon, top of the to-do list. It just makes the thing you're building more real and exciting. God, that's better. There, the app icon is updated. Doesn't this instantly feel so much more like a real app? And here's the change I actually made in my app.json. And here are all the changes that were generated automatically because my project is using prebuild. You can also extend prebuild with config plugins. Config plugins are basically little JavaScript functions that allow you to edit files in the native directories during prebuild. So you could write your own config plugins or use config plugins that are shipped with libraries. So for example, we used the React Native boot splash config plugin to configure the library for the Conf app splash screen. If our app didn't use CNG, we would have had to follow the instructions in the README to manually edit some of the files in the Android folder. But with CNG, we only need to add a plugin to our plugins array. So to better manage the native code in your app, you can generate it dynamically using continuous native generation, and use config plugins for any additional changes. Now, let's move on to the last and perhaps the most difficult part of native development, and that is the native builds and deployments. What do we actually need to do to get an app from your local machine to run on your phone? First, we need to have our build environment set up. That's not too dissimilar from web dev at a glance, where you need to have your node and your npm and such. But to build native apps, you also need some special tooling. So Android Studio for Android and Xcode for iOS. There is already some nuance here, such as you also need to install and set up Java for Android Studio, and Xcode, you can only get it if you have a Mac. Next, we also need to sign builds. Build signing is necessary for any native apps, and without it, your phone actually won't let you install it. So for Android builds, you need to create a key store. This is actually not too hard, and you can create one anytime on your local machine on Windows, Linux, or macOS. On iOS is where things get a bit tricky. You need a provisioning profile and a sign certificate. These are tied to your app ID and also contain information about capabilities that your app is allowed to use, so you need to keep them up to date. There's even more nuance to it, but suffice it to say, it's complicated. And this brings us, and this is exactly what we want to improve with EAS. EAS is a cloud service that helps you build, develop, and deploy React Native apps with ease. It bears repeating here that you can use the Expo open source framework without using EAS. And everything you can do with EAS, you can do without. It just might take you a little bit more work to set up and maintain. The main two things that EAS wants to achieve is to allow you to develop native apps without needing the native development environment set up. And secondly, we want to handle the hardest parts of native app development, which is the credentials management. With EAS, the builds are configured via an EAS JSON file and can be triggered via a CLI command. So by default, you have 3 build profiles with the 3 main types of apps you need to build. Let's focus on the local development build. Now, using a CI for local development might sound a bit unusual at first, but given that React Native apps, the majority of development is on the JavaScript side, it actually makes sense. Let me show you what I mean. A React Native app consists of 2 parts: your actual native app with the native code, and the JavaScript bundle with the React application code. In production, the JavaScript bundle is included within your native app bundle. But in development, you typically load this bundle from your local dev server, same as live reloading works on the web. So as long as you haven't changed anything on the native side of your app, this is the iOS and Android folders, you can actually keep using the same native app bundle for development. The Expo Dev Client enables just this. It's a library that adds additional developer tools to the debug build of your app. In addition to launching from your own machine or others on your network, you could open a version of your app running on a dev server on a colleague's machine on another side of the world, or even a build that's hosted on a server. Now that we have our JavaScript bundle sorted, this leaves the actual native app. You can always build this locally, but let me show you how you can do this with EAS. For my Android app, I can trigger a build using the EAS CLI. Since this is the first time I'm building the app, the CLI creates the project for me on expo.dev and asks me if I want to create a key store, the thing needed to sign the builds. Yes, please. My local code then gets uploaded to EAS, and the build kicks off. Once the build is finished, you can immediately install it on a local Android emulator or your plugged-in Android phone. The build artifacts are also stored in the cloud, so you can also install it directly from the website via QR code, which is handy for installing on devices, using Expo Orbit, which makes it easy to install it on simulators, or just download it for any other reasons. In fact, the rest of your team could use the same development build too. The iOS build is similar, only you get prompted to log in to your Apple developer account to generate the signing credentials. Recall how, during development, we use a local dev server to update the JavaScript code on the fly? Well, by a similar mechanism, you can actually update the JavaScript bundle on non-development builds as well, using EAS update. You can create the JavaScript bundle, JavaScript update, which will be downloaded the next time your users open their app. This can be handy for delivering small bug fixes to production, or sharing quick previews during development. On the web, we're used to doing PR previews as part of our workflow. With EAS Update, you can actually create PR preview workflow in your React Native app. Say you're working on the ReactConf app and you get a feature request. Could we add a link to the Conf Discord? Sure, that's a great idea, Lauren. Let's do that. So we make the change and raise a PR. With the Expo GitHub action, we can configure the update to be created automatically on each build. And the preview link gets added to the PR automatically as soon as it's built. So we can scan the QR code to open it on your physical phone from the PR, or open it on expo.dev and install it using Expo Orbit. This was the example of opening it on a local Android emulator. And we can do the same thing for your iOS simulator. This makes PR reviews way more palatable and more in line with what we're used to on the web. So far, we've been talking about the development build. Once you're done with development, you'll want to create your production build to share with your users. A production build is actually quite different from a development build. I mean, it doesn't have the dev client for one, but it is also a much more optimized format of your app, and is not even directly installable on your phone. And it also has different signing credentials. With the default EAS config you get out of the box, the development profile is set up to create the build needed for development. And the production profile creates the production build. So really, all you need to do is pass in the production profile to trigger your production build. This build will then be available to download from expo.dev, or you can use another service, EAS Submit, to submit it via CI. With EAS Submit, you can pick a build, either from EAS or from your local machine, and submit it to the app and Play stores. This spins up the submission worker on EAS and uploads your build. So for builds, both local and production, build signing, and deployments, we have EAS. Together, these are the tools that support you in building truly production-ready apps with React Native. Yay! Thank you. So to round off, throughout this presentation, you've heard us mention this ReactConf app a few times. We built it to show you an actual real-world example of putting everything abstract that I'm talking about here into practice. It shows you examples of a lot of the things that we'd commonly want to use in your app, many of which are mentioned in this talk. So we have navigation with bottom tabs and modals. We have data persistence. Have you noticed that it works offline? We have haptics, like when you bookmark an item or touch one of the tab bar items. We have animations, like the header scroll on the home page. We have light and dark mode, an animated splash screen, push notifications, an in-app web browser. And we also add some less common but perhaps interesting features, like has anyone found the secret modal? Well, one person has found it. Well, try pressing and holding on your app icon on the home screen, and on iOS, you might find a way to change your app icon. And finally, as a shout out to probably one of the most awaited releases from day one, it is, of course, using React Compiler. We've just made the repo public on GitHub from now on. So if you're curious to see how everything I talked about fits together, you can check it out. We added instructions on how to build this app on your local machine or via EAS. And now, for the wrap-up, I'll hand it back to Nico. Nico?
Thanks, Kari, for this amazing presentation of what Expo is capable of today. But now, it's time to recap what we learned. So we first talk about the state of React Native, and we talk about how Meta is using React Native and which companies are investing extremely hard on the success of this framework. Then we talked about new capabilities, such as the new architecture now being in beta. And finally, we gave suggestions for you how now you should build production-ready apps today in 2024 using a React Native framework like Expo. And with this, I want to thank you very much for listening and enjoy an amazing day 2 of ReactConf.